much you start with, regardless of how much you start with, half of it is gone. It's an interesting concept. If you start with 8 kilograms of this stuff, after 3,200 years you'd have 4. And after another 3,200 years you'd have 2. And then you'd have 1, and then you'd have a half, and then you'd have a quarter, right? You know, so it keeps on going down by half, right? Find the time it takes for the initial amount to decay by 35%. Decay means not grow, it means the opposite of grow, it means go down by 35%. So however much you start with, how long will it take to decrease by 35%? Now we're going to do a bunch of math to get the exact answer, but you can give me a range. It's going to take some time, right? But it's not going to take longer than what? It's not going to take longer than 3,200 years. Because if you go 3,200 years, how much decay would you have? 50%. So it's going to be less than 3,200 years. And it's hard to, it's not a linear function, it's a curve, right? It's going to look like this. It's going to curve down. It's going to lose a lot and then a less lot, right? It's going to slow down. It's going to be concave up. So let's make a guess here. Let's make some guesses here. This is fun. Let's make some. How long do you think it's going to be for it to decay? How long is it going to take to decay to 35% by 35%? What's our guess? What do we think?
2,000.
So let's say guess, sure, 2,000 years. So let's see how close that is. Now, the function you need to remember with respect to exponential growth and decay, you might have seen something like this before. Y equals AB to the t. Has anybody seen something like that? That's an exponential function. You can have exponential growth or exponential decay. Do you remember what A represents? The initial amount. The initial amount. I gave you a bunch of notes from a pre-lesson for this that if we had a lot more time we would go through. But A is the initial amount. So that's your starting amount. What's B? Anybody want to guess what B is? What's B? Oh, come on, you can tell me what B is. It's the rate. It's the growth rate. And could the growth rate be negative?
Yeah.
We'll call it the rate. That's fine. And what's T?
The amount of periods that.
Yeah, the amount of periods of that time. That's a very good way of saying it. Very good way of saying it. Amount of periods. It's time, but it's the amount of periods of time. You have to be very careful about that because the units will matter. The units will matter. And Y is just the output, like what the population is right now, or how much you have right now. So after a certain amount of time and a certain growth rate, starting at a certain amount, this is how much of the thing you have. Now, does it give us the growth rate? No, it doesn't give us B. Does it give us A? No. It doesn't, does it give us a starting amount? Does it say like 10 kilograms or 100 kilograms? No. By the way, you really don't want to be around any kilogram of anything, something radioactive like this. But generally speaking, we might get some of these values, but sometimes we don't. But what does it tell us? It says the half-life. So if this is the starting amount, how much is half of A? A over what? 2. A over 2. So let's set something up here. We know that 1/2 A is equal to A times B to what power? You get half of A after how long? After how long? 3,200 years. So we know, we don't know what B is, but we know that after 3,200 years, how much of the initial amount do we have left? Half of it. So let's solve now. It seems weird though, because how many equations is this? This is one equation. How many variables do you see? 2. So you might be uncomfortable, but what can you cancel immediately? You can immediately cancel the A's. And what are you left with now? You're left with 1/2 equals B to the 3,200. Does anybody remember how you would solve for B at this point? You can do it a couple ways. You can use logs, or you can take a root. What root do you want to take? To get rid of a square, what root do you take? The square root. To get rid of a cube, what root do you take? So to get rid of the 3,200 power, what root do you take? The 3,200th root, right? So that would be raising both sides to what power? What power? To the 1 over what? 3,200. So we raise both sides to the 1 over 3,200. I like it this way. So what do you end up with? 1/2 to the 1 over 3,200 equals what? B. So we now have what B is. So where can we plug that in? Where can we plug this in now? Back to the top. So what do we now have? We have Y is equal to A times, what's B? 1/2 to the 1 over 3,200. All raised to the what power? To the what power? Look at the equation. No, look at the equation. What power? To the t. We don't know what t is.
All we know is that b is that value. We know that b is that value. Are you with me so far? Okay. What does decay by 35% mean? How much of the thing do you have left if you've decayed by 35%? How much do you have left? 65%. So does it tell us a starting amount? Well, no. So the starting amount is a. So what do we plug in for y? What is 65% in decimal? 0.65 times a is equal to a times 1/2 to the 1 over 3200, all to the what power? T. What can we cancel on both sides? We can cancel a. We can cancel a. So we have 0.65 equals 1/2 to the 1 over 3200, right? To the t. How many variables do we now have in here? How many variables are in there? There's one variable in there, and there's one equation. So theoretically, can we solve it? Yes. When you see numbers like this, and you're asked to find an exact value, or close, that's 3 decimals at least, what do you think you're going to have to use? What do you think you're going to have to use? Your calculator. You think you're going to have to, yes, you are. You're also going to need to use logarithms to solve this. Raise your hand if you remember that you, at some point in your math career, you covered logarithms. Does anybody remember what the log form of that is? Y equals a to the x. What's the log form? Anybody remember? I'll start you off. Log base a of y equals x. These are the same. The definition of logarithm is this right here, that these are the same. If you have something y equals a to the x, this is the same thing as log base a of y equals x. Do we have that form right here? Do we have the same, do we have an exponential form right here? Absolutely. So in this case, here's our y, right? Here, a is this nasty thing right here, and t is that one right there. So if that's the case, can someone tell me what the log form is going to be? It's going to be log base what?
1/2.
Yep, 1/2 to the 3200 of what?
25.
Of, I like how you said of, equals. Hey, did we just isolate t? We just isolated t. What do we use to get a decimal for this? 17 years and 100 pieces of paper. Exactly. Use a calculator. Right. Use a calculator. You need to remember one more thing to type this into your calculator. Does anybody remember maybe what you need to remember to be able to type this in your calculator?
You need to go to like the log base.
So because the base on this one, is that the standard base you usually see? No. What's the base you generally see?
10.
You need to remember this. Log base a of b is the same thing as log of b over log of a. So in this case, what does t equal? Log of 0.65 over what? Log of 1/2 to the 1 over 3200. Everybody, do that on your calculator right now and see what... No. So let's pick a population. What's our population going to be at the beginning? That's a great number to pick, right? So after 0 years, we have 100 people. Okay. After 5 years, what do you have to multiply 100 by? What do you have to multiply 100 by to get 30% more people? 1.3. So how many people is that? That's 130. So at the end of 5 years, how many people do you have? 130. Nice. So after 10 years, what do you multiply by 1.3? Well, 130. Can someone do that on their calculator for me? I think it's like 16 something, 16.8. What is it? 169 point what? Is it just 169?
Yeah.
Oh, nice. Okay. Okay, so that's after 15 years. What do you multiply by 1.3? 169. Someone do that on the calculator. I think it's 200 and something.
219.7.
0.7. Nice. Okay, hey, we started with 100 people, and now we have 219.7. Are they doubled? It's more than doubled, right? So if we had to make a guess, what would our guess be? Let's make a guess right now. You know.
12.
What? 12? Okay, maybe our guess, maybe around 12. It's always hard to make these guesses because they're curved, right? It's either 12 or 13 or 14, somewhere between 10 and 15, right? All we know is between 10 and 15. But that's a guess. Let's be exact about it. Let's be exact about it. So it's doubling every 5 years. Does it say what our initial population is? No. So we're going to start with A. If you double A, what's 2A? And that's B to the, Do we know what b is actually? Do we know what b is? 1.3. It's always 1 plus the growth rate. 1 plus the growth rate to the t. Hey, what cancels on both sides? The a cancels, so you have 2 is equal to 1.3 to the t. What form is that in? This is exponential form. So what do you need to put it in? Log form. Can someone tell me what the log form is? Homework. Log base. Log base. Yep, of equals t. So you can either use just the base on your calculator or say t is equal to log of 2 over log of 1.3. Someone do that for me and tell me what you're doubling it, right? So you would multiply this times 1 plus the interest rate, so you end up with how much money? $2. Oh, that's exciting. Very nice. So you're multiplying 1 times the number 2. Very good. Nice. Twice a year. So if you had 100% interest and I said compound it twice a year, that would mean you do 50% once and then do 50% again. So if you have $1 and you want to grow by 50%, you'd multiply by 1.5. And then you would multiply by what again? If you're going to grow by 50% again? 1.5. So that's actually equal to? No. 2.25. 2.25. 2.25. And people are going to take out their calculators to help me in a second. Okay, so we did 100% once got us $2. 50% twice got us 2.25. Well, let's do monthly. How many months are there in a year? 12. So if we do it monthly, it's going to be 1 plus 1 over 12 because that's 1/12 of 100%. How many times do we do this? 12 times. Now, do I really want to write this out 12 times? No, it's going to be 1 times 1 plus 1 over 12 to the what power? 12. Somebody do that on their calculator, please. $1. E, what was our interest rate? 100%. In decimal, what's 100%? 1.00. And how many years did we have? 1. So that's equal to e to the first, which is e, which is what? 2.718. So are we ever going to get to $3? No, we're not. We're not. Continuous interest is the most you can make. Is the most you can make. It compounds continuously. Now, the way you'll see it sometimes is like this. Growth and decay. What's the only real difference between these two formulas right here? What's the only real difference? Yeah, it's P. It's called P and Q, right? But you could call it P. It's K and negative K. So decay means a negative growth rate. That's it. The only thing that changes is the sign of the exponent. The sign of the exponent. That's the only thing that changes. So let's try a few of these. It says, state whether there are growth or decay and find both the continuous and state the effective rate. Okay, so let's just do one of these to set you up because you don't know what effective rate is. I'll have to teach you what that is. That's totally fine. So let's talk about this. Yeah, so it's growth because 0.05 is greater than 0. Nice. It is growth. It is growth. So effective rate, this is super important. It's something that'll come up in real life all the time for you when you look to buy your first house or buy a car or buy anything where you might have to take a low property value. This is continuous interest, right? So it's going to be like basically the largest value possible depending on compounding. The question is, if you did this continuous interest for 1 year, 5% continuous interest for 1 year is equal to what interest rate once? So this is compounded every millisecond, right? What interest rate is this equal to in regular once a year, simple interest? What I mean by that is this. So 5%, remember if we did it once, let's say we had $100, right? And you took 5% interest, you'd earn $5, you'd have $105, right? But if you compound it continuously, would you have more or less than $105? You'd have more money, right? So let's say I said continuous interest, you want $105, you'd have a lower interest rate. So the key is this. This right here is the continuous interest rate. This is the same as what simple interest rate. Simple means not compounded, not compounded, not compounded. Now, what was that first formula we had? Do you remember what that first formula we had was? It was y equals AB to the t. Do you remember that, everybody? Is this almost this almost like this? It's almost, right? It's almost like it. What's the difference? Huh? The rate is split. It is decay. Good. Why is it decay? Why do you know it's decay? Because it's a negative growth rate. So it's decay since negative 0.025 is less than 0. So how do we go about finding the effective interest rate? What do we plug in for t? Plug in 1. So what is e? What's e to the negative 0.025 times 1? What is that right there? What does that come out to be? What is e to the negative 0.0251? What is that?
0.9.
Hold on, one person. Raise your hand. I'll call on you here. You got it? Okay, let's. 0.975. 0.975? Okay, so this is 0.975 times 100. Does the 100 actually really matter in this question? Nah, this is just like a starting amount, right? So look at this. This represents 1 plus r. So what does r equal in this case? Negative. Negative what? 0.2. What? You can use your calculator if you want. What is it? 0.25. Is that correct? 0. So this right here is t equals 0. What about 1986? What's that?
2.
T equals 2. Exactly. Assuming the population grows exponentially and continuously, find a formula for P of t, the population of Kenya, as a function of time. So I would like you to try this automatically. Yeah. So we know that's going to be 19.5 E. Do we know what the interest rate is? No. So then you have to figure, what do you put here and what do you put there? What do you think you put in the upper right, everybody? 2. But if you put 2 there, what do you have to put over on the left? 21.2. Exactly. So now